This lesson will review the relationships of the sides of a 30, 60, 90 triangle and a 45, 45, 90 triangle. Knowing these relationships will help you on the ACT college entrance exam. Now let's head over to the classroom to review these special right triangles. Okay, let's talk about special right triangles. The first one I want to talk about is a 30, 60, 90. So let me draw that kind of triangle. I want to put a 30 and a 60 here. Now there is a relationship of sides. The side opposite the 30, I'm going to put x. The side opposite the 60, I'm going to put x radical 3. And the side opposite the 90, I'm going to put 2x. Some teachers will write 30, 60, 90, and then they'll write x, x radical 3, and then 2x. And that's fine. I'm just trying to show you a couple different ways of relationships of the sides in a 30, 60, 90. Now say I gave you a right triangle, a 30, 60, 90. And I gave you only one measure. The length of opposite, the 90 degrees, which we like to call the hypotenuse. That means, well, you can't use Pythagorean theorem. You have to have two sides to use Pythagorean theorem in a right triangle to find the missing sides. So we got these 30, 60, 90 going on. We got the side opposite the 90. What I'm going to do is I'm going to take that 2x, which is with the 90, I'm going to set it equal to 1, and I'm going to solve for x. So you divide both by 2, and you get x is equal to 1/2. That means x is opposite the 30. So opposite the 30, if I put a 1/2 here for the x, that would mean this has got to be a distance of 1/2. Then opposite the 60, I'm going to put a 1/2 for this x now that we solve for x. The main thing is to solve for x first, and then you can find the other sides really quick. You're going to put a 1/2 for this x, and that would give you 1/2 times the square root of 3, or we like to say radical 3 over 2. If you know that this 30, 60, 90 relationship, you can get both those really quick, and speeding actually is crucial in the ACT exam. Now let's take a look at another triangle. Let's put 60 here, and 30 at the bottom. And let's put 4 opposite the 60 now. So if you want, you can write your 30, 60, 90 real quick. X, x radical 3, 2x. Now you have to ask yourself, well, what side did they give you? Opposite what angle? That's what's crucial, how you start this. Well, you got the side opposite the 60. So that's 4. So you're going to set this x radical 3 equal to 4. And then what you got to do is you got to solve for x. So you're going to have to divide both sides by radical 3. So you're going to get x equals 4 over square root of 3. And if you remember from the radical section, we can't have a radical on the bottom. So we're going to have to multiply top and bottom by radical 3. So x is going to be 4 radical 3 over 3, because square root of 3 times 3. Square root of 3 times square root of 3 is 3. So it's telling you that we basically got x equals 4 radical 3 over 3. That would be for the side opposite the 30. So I'm going to write 4 radical 3 over 3 for that one. And then for the 90, you're just going to double that answer. So if you took 2 times it, basically all you're going to do is multiply this 4 by 2, and you're going to get 8 radical 3 over 3. Can you see something that complicated on the ACT? I bet you. Okay, let's take a look at one more situation. Say I put the 30 degrees up here now, and 60 in the bottom. And I give you the side here at the base. So that would be the side opposite the 30. So if you have your 30, 60, 90, you know that's x, x radical 3, 2x. They gave you side opposite the 30. So they're telling you x is equal to 7. That's easy. So we know x is 7 right away. We don't have to do any dividing or anything like that to find x. We got it already. So we know the side opposite the 60 is put a 7 with the x. Here you're going to get 7 radical 3 here. And then for the opposite the 90, it'll be 2 times 7, and you'd have 14, and you solve that right triangle. Now let's talk about 45, 45, 90s. 45, 45, 90. Let me go ahead and write it out here. 45, 45, 90. You'll notice that these angles are the same. You can kind of look at it. That's a right isosceles triangle. So the sides opposite the 45's got to be the same length. We're going to put x for that. And then for the side opposite the 90, that would be x radical 2. So if you want, I'll draw them in there so you can see. So you'll opposite the 45's, we'll put x. And opposite the 90, x radical 2. So that way you can see it. Now let's take a look at a couple situations. We got to put our angle measures in there. And let me give you the side opposite the 90. So if you were doing this relationship, they would be giving you this side opposite the 90. You would take that x radical 2 and set it equal to 3, and you would have to solve for x. So you'd have x equals 3 divided by radical 2. Uh-oh, you got another radical situation on the bottom. We got to multiply top and bottom by radical 2. So that's going to give us 3 radical 2 over 2. That's what x is. Well, that's going to have to be opposite both the 45s. So you're going to have 3 radical 2 over 2 here, and 3 radical 2 over 2 on this side. Not too bad. Let's look at one more situation. We're done with the 45, 45s. Let me draw it a little different. Let me draw it kind of like upside down from what I've been drawing. And let me give you the side opposite of 45. This is the only two possible situations you could be given. So say you're given that side opposite of this 45, this 4. So if you want, you can write your 45, 45, 90, x, x, x radical 2. And they're giving you the side opposite of 45. Which one doesn't really matter. This one's got to be the same. And this one's got to be, put it at 4 right here for the x, because you already know what x is. So this will be 4 radical 2. And that's as easy as it gets.